Welcome back. So we'll start. Is there any question from anybody? Okay. So if there is no question, I am starting the second part of today's lecture, and I believe the recording is on and we have the getting done. So we'll talk about primarily three concepts here. Okay, and these are classified as advanced SQL, but these are very much part and parcel of any form of application development using databases. So one of it is use of functions and procedures. So first thing if you notice is that mm, we so far have talked about using SQL for accessing data. Okay. But of course, as you can see that there are many things that you cannot possibly do in using SQL, like writing a for loop or something, doing some if, then, etc. So when you are developing a database application, you of course will need some more freedom to write your application program. So for that, since the very beginning, as you can see, 1999. Okay, so that was quite some time back. Okay, more than 20 years back. What it allowed was that it allowed to define functions and procedures, and that can make use of other types of languages or maybe some extensions of SQL itself. Okay, so different database vendors, they developed with their these extensions to SQL for developing these stored procedures, what are called stored procedures or functions, and their languages are also named by them, like Oracle calls it as PLSQL, and SQL Server calls it TSQL, and so on. So what happens is that in these you can include many more high level language type constructs. Okay. Besides this, also what you can do is that you can embed SQL calls in many programming languages. Okay. So as part of your lab assignments after maybe next one or two at most, if you see that the schedule that I have shared, that talks about doing a mini project. So first it would be a browser based application, the regular browser based application, and the second part will be mobile Android app. Now of course you have to form a group and so on, and you have the dates by which you have to convey us those details. But what you have to do is that in that application you will have to have some database in the backend, and then you will have to have some kind of a GUI through which you will access the backend database. Okay, and this GUI you can build in using any language. You can use PHP or anything that you want. And why I am saying that in this context is that you need to, of course, finally talk to the database by using SQLs, and because SQLs do not have full features of a programming language. So that's why we need to have some way where we can have some more logic, like looping and branching and so on. So what is supported in SQL is this concept of functions and procedures. And as mentioned, the very last point, as I already said, that the databases have proprietary procedural extensions to SQL like TSQL and PLSQL and so on. One so we see a general syntax of SQL function. So just remember that this is what it is shown is a general form. Okay, do not expect exactly it to work either in MySQL or in Oracle. Okay, I would suggest that from this part onwards, your assignments you focus more on Oracle, because Oracle is likely to support more features through its PLSQL extension as compared to MySQL. Because Oracle is used in many commercial applications, which are often complex applications, so they need richer support. So that is why we focus on this MySQL. I'm sorry, this SQL functions with respect to PLSQL, and it would be also good to know for many companies if you say that you have written some these functions and procedures in I'm sorry, in PLSQL, Oracle's SQL extension. So that would really enrich your resume. Now coming back, so this is a general form. What it says is that you define a function, like you have a function in any programming language, where you have the function name and then some parameter, and you say what it returns, and then between begin end you can have some that you see that you have uh, variable declaration, okay, and then uh, you see select count star into decount, so you can read that count star, so you have that select, but you read it into that variable decount which you have declared, and once you have done it, so you can return decount, but before doing it you can say if decount greater than 100 return 0, else return 1 or whatever, okay. So you can do those kinds of processing here depending on what all such language constructs are supported by the respective SQL extensions, that is PLSQL or TSQL and so on. TSQL is for these database, these Microsoft, I mean the SQL Server database. So, so the function department count. Now, once you have defined that department count function, okay, then now you can use it like any other function. So you see that now you can have select department name comma budget from department, where now you are calling the function department count with the department name, okay, and then for every row that will be returned by this select, it will be calling the department count function with the department name, and whatever it returns, so of course that will return an integer which is a count. So you can now have department count and in bracket department name greater than 12, okay. So you see that this is now as if this is like for built-in functions also, right? You can have this max, mean, and average, and so on, or count. So it is similarly that you can have this function used inside any other SQL. Okay. So of course, as you can see that because of being able to reading into a variable like decount, after that select, you can, as I said, that you can do more processing and so on, and return it, which you cannot easily do using SQL. And this it's not necessary it will have only one such select. It can have many such selects, and you can do a lot of things inside the function. So overall, it is a compound statement with between begin and end. And as I just now mentioned, may contain multiple SQL statements between that begin and end. And returns indicates the variable type that is returned. Okay. And return is specifies the value that is to be returned. And of course, these are, you can consider that it is in some sense some parameterized views, that when you can pass something and based on that this view will be executed, but it is actually more than that, because a function can have beyond being uh, parameterized views, they also allow these types of constructs, and you can do if else etc, which of course you cannot do in parameterized view. So it's in its simple form it's like parameterized view, but it is much richer than being called as a parameterized view. So that was about that returns this value, okay, and then added functions that returns a relation as a result. So what you can do is that you can also not only return such values, you can return a relation, okay. So for example, we have a create function, and then we have a department name, and then we say that returns table, okay, and then we say what will be the structure of that table, and then what we are saying, then you return table, then select ID, name, department, salary from instructor. Now you see that we are able to join that instructor dot department name equal to instructor of dot department name. So what it shows is that instructor of dot department name is the department name that is passed as the parameter. Okay, you see that name of the function is instructor of, and that is pass this parameter department name. So this is a unique way of joining where you are saying instructor dot department name equal to not department name of another table, but that of which is the formal parameter department name of the instructor underscore of function. So that means that if I call it, now you see the usage that select star from table, then what you do is that now which table? This table you are writing instructor of and then music, means this instructor of music, it is calling the instructor underscore of function with the parameter music. So that means this function will be called, and what does it return? It returns basically this ID, name, department, salary, a simple form as is shown from instructor, and only those instructors for which the department name will match with the department name that is passed as parameter while calling the instructor underscore of function. And when it is called with music as a parameter, so effectively this function call will return a table which will have those columns ID, name, department name, salary. Of course you could give your other names, not the exact names that are there in the table, because it is your choice what name you want to give. You could call it identifier or full name or whatever. And then we have to ensure that when you are using it in any select, you are using that appropriate names of the tables that is returned. Okay, so you see that it is very powerful. And like functions, so some languages support only procedures, some support functions or both. So procedures are also similar to functions, okay, but typically this return, like the way you say return here, it does it in a little bit different way. What it does is that it has got some of these parameters marked as in and some are marked as out, okay. And you do not explicitly write return. What you do is that you assign some value to that out parameter, which actually will get a return. Okay, so as you can see that select count star into decount we are doing, and decount has been declared as an out type parameter. So whatever is the value of decount from that that select statement, so that will be returned when that procedure is called. So procedures can be invoked either from an SQL procedure, so one can be invoked from the other, or from an embedded SQL in some high-level programming language. And you can call like this. You can see that call department count proc physics and decount. So what it will do is that it will pass physics as the input parameter to the deep count proc procedure, and whatever it is returning, it will be assigned to the decount variable. Okay. So these are all some of the important extensions of SQL, because people felt that we need some sort of these extensions. These are often called 4GL. That used to be called as the fourth generation language. So these PLSQL, TSQL, these are often called 4GL languages. So, some more details about you can have, as I said, that while, repeat, and all those things you can have support for them, but that varies a lot from one database system to another. So, as I said, that you can have a for loop and so on. Okay. So those things you need to take a look at the manual of the particular uh, database system you're using. And as I said, that for our lab in next week, so when we do this advanced SQL, some of these things, it would be uh, good if you use Oracle. So next we move on to this concept of trigger. Okay. Now, trigger is something that is again an interesting concept in databases. Say, let us take this example. I'll give you an example and which will make the whole thing clear to you. Uh, Say when we submit your grade for any subject, okay? So we get a message that updating, saving grades and updating CGPAs, okay? So what does it mean? It means that suppose I enter grade for one subject for all the students. Let us consider one particular student. So what I do is that for DBMS, for student roll number 1, I enter a particular grade. Okay. So that will get stored maybe in a registration table or something, which will have columns like roll number, course code, maybe semester, and year or something, and then the grade. Okay. Now, uh, so that means that for every student, I can enter for that subject the grade, and maybe for other subjects also, other professors will enter the grades, which will also get stored in that registration table. Now, what we have is that we also have a course table where for DBMS it will be mentioned how many credits are there, right? So 5 credits will be there against DBMS in the course table. And there is a student table where I have roll number, name, and say current CGPA. Okay. Then what happens, you see, so let us focus on these 3 tables. I have a student table, roll number, name, current CGPA. I have a course table, course number, and then course name, and then number of credits. And then I have this registration table where I have, for simplicity, let us assume I have roll number and then course number, and then we have the grade. Okay. And somewhere, of course, we know that let us, for this, for simplicity, that grade, let us consider that instead of these A, B, C, D, etc. So or whatever. So let us have it as these EX, A, B, C, D, etc. Let us not worry about it. So the point that is important is that when we enter anything in this registration table, a grade, what we want is that the CGPA also to be automatically recomputed. Okay. So when I enter a grade, the CGPA gets recomputed based on total number of credits so far done and current CGPA, and then you know how to do that. And if some other professor enters another course's grade for the same student, again the CGPA will get updated. If I, for example, find that, oh, there should be an update in the grade, I made a mistake, or there was some reason to update it later, then as it is updated, then again I would like that the CGPA be recomputed. But what we want is that this is to be done all the time whenever there is a change in the registration table where that grade value is changed. Okay. So if it is deleted, for example, for some reason that after this thing student decides to maybe go for another course or something, like for upgrading the CGPA or whatever, and this will be overwritten or like say deleted, then again the CGPA needs to be recalculated and so on. So what we want is that these things should happen in an automated manner, that I don't have to write a code to insert maybe a row in the registration table and also write another SQL to update the value in the CGP, in the student table for updating the CGP. So because what happens is, if we write it, then if somebody does not use the whole code, a part of that is used, then there will be a discrepancy between the actual grades the student has in the registration table for various subjects and the CGPA the student has in the student table. So, so this is done using what is called a trigger. So in that registration table, we'll write a trigger so that whenever there is a change in the grade of any student, be it insertion, deletion, updation, it will also go and accordingly update the value of the CGPA in the student table. So that is the whole concept. Okay, and that is what is called trigger. So we'll see some general syntax for trigger, but again, as I have written here, the last one, that in your particular database system, the syntax could be a little different, but this is the basic concept. So what we do here is that we say that create trigger, okay, and then we give a name of the trigger, and then we say before update of text. Before means actually the update before it is updated, a row is updated, just before that it will do it. And then of text means that is the name of a table. Okay, so the overall syntax is, I have a name of a trigger, I have to specify on which table it will operate, like in our example it is a registration table, and on what condition, is it for insert, update, or delete. But select, of course, there is no trigger. So this before update, before I am coming to later, so it is update, insert, or delete. Before means before actually the update is done, whether you want to do something, or after update has been done, whether you want to do something. So, and referencing new row means that when you are updating, so updating means there was an old row, and suppose I update some students grade. Okay, so roll number 1, and then subject ID 1, and then grade was something, and then I change it to something else. So then this new, so there, you see there will be two rows. One is the old one, the other is the new one. But of course, in the table it will be having only one row. The previous value will be updated, but notionally, when you are updating, there was a pre-image and there is a post-image. Okay, so this pre-image is what is called the new row, and the post-image, sorry, the pre-image is called the old row, and the post-image is called the new row. So new row is a keyword. So it says referencing new row as, then you give a name that you want to give. We call that as n row. And then for each row, okay, so when nrow dot grade equal to say blank, then what we do is that we set it to null. So basically what it is doing is that if someone is entering the grades for students, and if one student's grade is blank, then it is setting that grade to null. Okay, that is all it is doing. Okay. So create trigger, set null trigger. So you understand what that means. And then new row is referred to as n row. And what it says is that, say the old grade was say ex, and now it is being changed to blank. Okay, then n row dot grade will be null. And then what it does is that it is going to set it to, if it was blank, so we want to set it to null. So this trigger will do it, so that actually in this table itself, what will happen is that if someone wanted to update, what is the net effect of this particular trigger? If somebody is updating an existing grade to blank, blank means space here, then that will be actually set to null. That is all it is doing. Or you could say that if it is set to this space, you want to set that value to something like say t or something. So you will say set n row dot grade equal to t. So when that is going to go in, it will, instead of being stored as a blank, it will be stored either as null or whatever specific value you want to mention. Okay. So this is again that example that I mentioned. So it is like this, that this is for update of text on grade. Text is like that registration table I was talking about, and grade means, so this is important. You can say update of text on grade. Here I had update of text. So I can say on grade means only when that column is updated, the trigger will get fired. If any other column is updated, it will not get fired. Okay? So here you see referencing new row as n row, old row as o row. And then for each row, what it is doing is that if the new grade is not equal to f, and new row is not null, okay, so then old row grade is f and old row grade is null. So that means that now I am trying to update it. So what we'll do is that update student. So that means that total credit will now be updated. So if the new grade is not f, okay, that means the student did not get an f. So then the total credits will be added. That's all it is. Okay. So it will get the total, the number of credits from the course table for this course, and say the student had already cleared say 100 credits. This course has 5 credits. It will update it to 105. That is all it is doing. Okay. And of course, if the grade is not F, if the grade is F, then of course this credit has not been cleared, so it will not do. That is all. Okay. And also if the value entered is not null. Okay. So that is what it will set. Okay. So you see that this is an example which is similar to the example that I gave, where we update the credits earned by means of a trigger. And the advantage, as you see, that no matter in whatever way this grade is updated, whoever is doing it, the trigger automatically will fire, and it will update the total credits for the student cleared, and it will keep the database in a consistent state all the time based on the grades that the student has got, and the credits that the student has cleared. Okay. So, and also you see that these are two different tables. As you can see, update on text. So whenever there is an update on the text table for this grade column, and it is going to update the student table with the total credits cleared. So why you want to do it? Because if there are other things that are changed for some reason, you may not want anything to be updated. So this is what is called a trigger. So now what you can do is that this shows that it is for each row the trigger will get called. The other option is that you can also have the trigger called for each statement. That means a statement can affect multiple rows, but this trigger will get fired for that statement only once. Okay. But then a statement can affect multiple rows. So you may want to actually referred to each of these rows. When we talked about this for the row level trigger, so in that case, what was happening was that you only have this notion of new row and old row. Okay, as I said, that post image and the pre image, that is for only one row. But when you have a statement level trigger, so this statement means that it will affect multiple rows of the table. So you have a post image of the table and a pre image of the table. So you reference, you call that old table and new table, just as you had old table and old row and the new row in this example. Okay. So, so there you can also define these triggers, as I said, for this for the statement level for any transaction that updates maybe multiple rows. So, for example, our when we submit a grade, we don't submit for one student at a time. We enter the grades for all the students and say submit. So that submit is a statement which will cause a statement to be executed, which may affect say all the say 100 students in a class. So what it will do is that it will fired the trigger once, but inside the trigger, it will process all the rows that are affected. Okay, for each row, it will update. So the value of the say the CGPA in the respective rows of the student table for that all the students who were affected by that grade update. So sometimes you may or may not use triggers. So triggers are very useful. So if you remember, we talked about the materialized views. Okay, we said that if we have materialized views, whenever there is some change in the data in the underlying tables, we have to update the data in the materialized views. But because otherwise, what will happen is that the data in the materialized views will be stale. So today I have updated the materialized view and it is in sync with the base tables, and tomorrow I change the data in the base tables. So if you do not accordingly update the data in the materialized views, so there will be inconsistency in what is there in the materialized view with respect to what is there in the underlying table. So you may want to use triggers to update the materialized view, and sometimes people suggest that you may or may not want, because if you do not want the materialized views to be updated immediately, because this trigger will take some time to execute. So every time you change data in the base table, if there is no need to update the materialized view, it is okay to update the materialized view from time to time. Then you may not use a trigger. But if you want to update it and keep them in sync all the time, you can always make use of such concept of triggers. So there are many times when you may not use triggers, and there are some other situations. Okay, so I will not talk about this now. Later on, when we talk about data recovery, in that context, I'll talk about this concept of replication, and then I will actually tell you what is the meaning of using triggers and what could be the implications of the triggers when there is some replication of the data. Okay, so we'll talk about this point in that context. Otherwise, it will not be clear to you if I talk about it now. Is there any question up to this? So in the advanced SQL, as I said, that we'll talk about these three concepts. Okay, so one is the stored procedures and functions, which I have mentioned. Then I talked about triggers. So again, I would suggest that you see for Oracle for the assignment next week, that how to handle these triggers in Oracle, its syntax and so on. Similarly, stored procedures and functions in PLSQL. And finally, I will talk about this concept of what is called recursive query, okay, which is also a type of query which is often required. So let me take this example. Okay. So if you see that we have, for example, say our database course. So DBMS has got a prerequisite of discrete structures. Okay, and then say discrete structures has got a prerequisite say of PDS. Okay, and now suppose we have advanced database systems course which has a prerequisite of DBMS. Okay, so of course we have a course table where we'll have all these four courses: advanced database systems, database management systems, discrete structures, and PDS, and all of them will have their number of credits, etc., in which semester they are offered. So those are there in the course table. And there is a prerequisite table where we will have the course name and its prerequisite code. So for advanced database systems, we will have DBMS. For DBMS, we will have discrete structures. For discrete structures, we will have PDS. For some other course also, we could have discrete structures. Okay, so let us assume that for graph theory, we have discrete structures. Okay. Similarly, for say advanced database systems, we could say database is prerequisite, and also not discrete structures or PDS, but something else. Just let us consider that algorithms is a prerequisite, something like that. Now, what we want is that for any course, I want to see what are all the courses for which are the prerequisites. So, if I want to figure out for advanced database systems, what are the prerequisites, how will we find out? Because if I see the table only shows that for advanced database system, that DBMS is the prerequisite. But the fact that it also has uh, mm, uh, transitively dependency on discrete structures and PDS, that will not show up. Okay, so how we can do that? So is there any suggestion how it can be done? So if we know that there is only two levels, the first level like ADS has DBMS and DBMS has discrete structures, then what we can do is that we can write a select on this prerequisite table, comma prerequisite table, and call the first one as T1 and the second one as T2. And then I can make this T1 dot prerequisite code equal to T2 dot course code. And then if we do it, then of course we'll get the not only the after the first level, I can get the second level. Okay. If we know the total maximum number of levels, we can do so many such joins and we can do a union of that. But when we do not know it, like in the prerequisite case, we do not know how many levels we have to join, because sometimes I may have one level of join, sometimes I may have two levels of join, sometimes there could be n level of joins. We do not know. So in this case, it is something that you cannot easily do by just writing a SQL where you will write so many type number of joins, where you do not know how many levels could be there. So that is where this notion of recursion in SQL comes into picture. So what you can do is that you can define it like this with recursive. Now you see this structure that you are saying with recursive, then you give a name, okay, that is like a temporary table name that you are giving, that rec underscore prerequisite, and then you give the names of the two columns you want to give, say course ID and prerequisite ID. And then as now it is like the base condition. Okay, like in recursion you have the base condition, so you basically take the first level of prerequisite from prerequisite. So you do select course ID from a prerequisite ID from prerequisite. So that is the first level data that you will have. Now the interesting part is then you do union, and then what you do is that now you are doing a join between this rec underscore prerequisite, that table, and the existing base table, which is the prerequisite table. Remember that that rec underscore prerequisite is not a physical table. It is within this query itself you are defining. Okay, like with, and then you can have a temporary table name that you can give in normal SQL. So it is similarly, but it has this with recursive clause. So you do a union of that with, now you are picking up this select rec underscore prerequisite dot course ID, and then the prerequisite ID from the prerequisite table, and you see from this rec underscore, so it should be pre-rec, don't take it as rec. So there is a typo, it should be pre-rec. Okay, so let me correct it here itself. Okay, so it should be rec underscore pre-rec, comma pre-rec, which is the existing table, and you join the prerequisite ID of this rec underscore pre-rec with the course ID of the pre-rec. Now that is what you would have done if you knew normally there is only two levels of prerequisite, like advanced database has database and database has discrete structure. In that case, this recursive will not be required. This itself will have would have returned the result. Okay, so this would return for ADS the database scores from this one, and from this part it would return data the discrete structure scores. Okay, but the fact that the discrete structures can have PDS and PDS can have something else. So if you do not know to how many level you have to go, you just put this with recursive. So then it will automatically go all the way, and it will keep adding to the result set of this union until it does not have any more new result sets that are getting added. And with this, now that means that I have defined a table called rec underscore prereq with these two columns. You write select star from this, so that what it will do is that now it will retrieve for every course its prerequisite up to any level of detail. Okay, so it will return it will return these rows like ADS DBMS, then ADS discrete structures, ADS PDS, and DBMS discrete structures, DBMS PDS. That is what it will retrieve if there is no and also discrete structures PDS. Okay, so if those are the ones that we have. So you see that it is very powerful. Okay, so effectively this is what it is doing is it is computing the transitive closure of this prerequisite relation, and this is something very useful when you need to go into some unknown number of levels of such depth of recursion. And also that stopping takes place, which you need not worry, and that is the beauty of these database management systems. And these are why sometimes it's called non-procedural languages, means you don't have to write the exact procedure how it will happen. So you are writing what you expect, and how it will be actually done is not something you need to worry about. So it's not procedural, so it's called non-procedural language. So what you do is that you specify what exactly you need, and as you see that in the execution process, it will keep adding more number of rows to the union as it keeps going to different levels of depth of recursion. And when it finds that it is not adding any more rows, it knows that I have bottomed out, so it will stop that on its own. Okay, so this is also something that you notice that if somebody is having an access mm, to the book, in the book chapter, actually for chapter 5 where they are talking about recursion, so they have a misprint. Okay, so just make sure that you follow what I have shown in this slide. And the power of recursion, of course, that we all understand that how it is working. As I said that for uh, we can, without a recursion it will be very difficult to write this it can do a fixed number of joins, as I said. But if you try to do it using any stored procedure, then you will have to write some kind of these loop, and till it adds any more rows, you have to do all those things. So so that is what you need not worry about when you are using this with recursion clause. Sorry, I'm sorry, with recursive clause. Just make sure that in your respective database that you are using, as I again said, that the syntaxes could be always a little different. So you just have to ensure that you are following the correct syntax. So one more point before we close. So these are the sections or subsections that you need to focus on from the book for the sixth edition, 5.2, 5.3, and 5.4.2. You don't need to look into all the other sections in this chapter. But before I close, can somebody give example of another example of where such recursion might be of use? Another query where you might need, if you have understood this concept. Any idea? Let me give you another example. Suppose there is a mm, there is some machine. Okay, so let us take a simple example. Suppose we have a bicycle. Okay, so if we consider a bicycle, so what are the items you need to construct a bicycle? So you can say that first level, you can see that I can say I will need some, say, wheel, I'll need say a seat, some frame, and so on. Okay, then what you can say is that so you can say also I need two wheels, okay, one seat, okay, and one frame, and so on. Then you can say a wheel needs what? A wheel needs tire, wheel needs, say, some 24 spokes, okay, it needs, say, 50 ball bearings, okay, it needs a rim, okay. So now if we consider each of those, the spoke can again have something like, so it can have one of these subparts, they can have like a nut and a bolt and so on. Okay, so if you see that kind of situation where what you would like is that if I want to say uh, say I want to set up, say, the 100 bicycles. Okay, I want to know how many total number of such ball bearings I need. Okay, so different parts can need different number of ball bearings. So what I would need is that for one bicycle, I have to figure out how many parts, and then they have how many sub parts, and then at the very lowest level where you are having those ball bearings, so you have to figure out that many parts need many different number of ball bearings. So total for each bicycle, how many such ball bearings will be required. So directly you cannot know, because first of all, for a cycle you may not be able to write how many total number of ball bearings. You have to write it for individual little level of subparts and so on. Okay, and many of them may need different number of ball bearings. So what happens is that you finally will need to do these types of recursive queries, so that you can figure out that for actually like constructing 100 bicycles, how many such ball bearings will be required. So that is another example where you may need this notion of recursive queries. One more concept, let me tell you, because now that I have told you about recursion in SQL, let me tell you a little bit, go back and tell you a little bit about trigger. Okay. Now in trigger, for example, suppose for one table T1, you have written a trigger, like say on update, which does something like say update something in another table T2. Like we said that if we insert, for example, grade in the registration table, it will update the CGP in the student table. Now, suppose in the student table, again, I have written a trigger for update, which will in turn go and insert or delete or update another table. And then that can have another trigger and so on. So what can happen is that this way you can cascade the triggers. Okay. The other possibility is that whether, say, if I have a table and I define a trigger on it, and the action of the trigger will cause an update on the same table itself. Okay, so in that case, what happens? In that case, again, it has nothing to do with recursive query. Okay, recursive query is only about selecting, but recursive trigger is that one trigger is causing another trigger to be fired, which in turn causes in a cyclic manner, finally in a loop, it will cause the first trigger to be fired. So it can go up to many different such intermediate points and go back to the first trigger getting fired. Or it could be just on the same table, I have a trigger, but the action of the trigger on the same table causes the trigger to be fired again, and then that will again cause an update, which again cause a trigger to be fired again, and so on. So that becomes a recursive trigger. Okay, so a possible example is that say if I have, say, a person in a company, so I have employee and manager. Okay, and then that manager will have another manager, that manager will have another manager, and so on. Everything is there in the same table, and there is a sales value. So if we say that if an employee makes a sales, it will not only update that employee's sales, it will also update the sales of the employee's manager, and also that of that manager's manager, and that manager's manager's manager, and so on. Okay, So you see that that way we can have this requirement that if now I have this table, again I am repeating that the table has columns employee code, manager code, and sales. Okay. So now what we'll have is that for every employee the manager is maintained here. Okay. Or we could have that employee to manager, that is like a separate table where we'll have that employee manager, these two columns, and I'll have all levels up to this, and this first table will only have employee and sales. Now if now what we do is that if we update the sales of one employee, it will figure out from the other table who all are the managers. So there you can write a recursive query to get all the managers and then come back and update the sales here. Or here if we maintain the recursive trigger, what we can do is that if this is the structure is employee code, manager code, and sales, and if I update the sales value, then it will uh, mm, uh, fire the trigger to update the sales of the manager, and then that in turn will update the sales of the manager's manager, and so on. So you could also have a possibility of doing such recursive triggers. But recursive triggers are very risky. Just you have to make sure that the triggers will finally will come out of the recursion, and that's why the databases often do not allow recursive triggers to be fired. So there is often a global parameter which is like set recursion on. So only when you have done it for the database, that then only the recursive queries will get fired. Okay. Recursive, I'm sorry, let me repeat. So if you set recursion on, then only the recursive triggers will get fired. Recursive queries do not have an issue because recursive queries are select and then it will stop. But recursive triggers is a problem. So let me again say it correctly that recursive, this set recursion on is with respect to the the recursive triggers. Okay, because these recursive triggers, if they keep firing and if you have not written the trigger code in correct way so that it will stop when there is no need to update further, otherwise it will try to keep on updating the table repeatedly, endlessly. Okay, but recursive queries are fine. Okay, so they do not have any issue, and you can have those recursive queries. So this is something I thought of sharing with you, which is not there in the book, but it is very interesting that to what extent you would like things to be done using triggers, and what you would like to do on your own, writing stored procedures or something. So these are choices, because if you have certain such updates written in the form of triggers, the advantage is that no matter in whichever way the base table is updated, like that registration table, as I said, that it is updated with with the grade of a student, the CGPA will always be updated. Okay. So if you did not write it as a trigger, if you wrote it only as maybe a stored procedure, and then used it in your GUI, then what would happen is if the GUI only is used for the updating of the grade, then the CGPA will be calculated correctly. But suppose someone in ERP goes and directly changes the data in the table, then that unless there is a trigger, it will not go and update the CGPA. So there will be inconsistency, and you will never be able to figure out how the inconsistency came in. So these are some of the practical aspects that one has to keep in mind when developing database applications. Mm, that's why I'm sharing my own experience with you. That these triggers are very powerful, and they actually help to maintain the database consistency, because no matter however the table is changed, either from a front end GUI or directly through a script in the back end, somebody firing a query, the insert or update statement on the table, the registration table in our example, always the CGPA will be consistent. Okay. So those are some of the things that are very important concepts that one needs to keep in mind for SQL. So, um, so this is about some of the advanced concepts, stores, procedures, and functions, and triggers, and also the recursive queries. And again, do not get confused with the recursive queries and the recursive triggers. Okay. Mm. So recursive triggers is when it is firing because of the trigger action itself. The same trigger is again getting executed. The other is about recursive queries where you try to fetch that multiple levels of detail where you do not know to what level you have to go. So that will bring us to the end of our discussions here on advanced SQL. So next week we'll take up topics from chapter 6. So we'll stop here. But if there is any question at any point of time here, you may please ask. So if there is no question, I am stopping the recording now.